Okay, we're going to do an example of multiplying two complex numbers in polar form. I've got two complex numbers written on the board already in polar form for us to do the multiplication with. I'm going to multiply them using the thing we just worked out, and then I'll also find their a plus bi forms and use the distributive property to compare my answer to that answer. So let's look at this. So we've got z is root 2 cosine pi over 4 plus I sine pi over 4, and w is 3 root 2 cosine 3 pi over 4 plus I sine 3 pi over 4. So z times w, let's write it out. So z times w is going to be root 2, and I'm going to group the magnitudes together already because I know that's going to happen. And what we do with their angles is we add the angles. So we've got pi over 4 plus 3 pi over 4 and plus sine of pi over 4 plus 3 pi over 4. With my I, forgot about the I hanging out. Plus I sine. Okay, so we're going to multiply our distances root 2 and 3 root 2, and then add the angles together, pi over 4 plus 3 pi over 4. See what we get. Well, root 2 times 3 root 2 is 3 times 2, which is 6. There's 6 right there. And then pi over 4 plus 3 pi over 4, you got a quarter plus 3/4, which is a whole. So this is cosine of pi plus I sine pi. Whoops, dropped my I again. It's a bad habit. Don't do this. Keep the I, keep it around. So let's calculate each of these numbers. Well, I mean, that's one way to write the answer. We leave it like this in polar form. But if we calculate cosine pi and sine of pi, those are easy to find. Cosine of pi is just the number -1. -1. And I sine of pi is the number 0. So we've got -6. That's the result. Okay, so our answer is -6. Now what I'm going to do is I'm going to go back to z and w and calculate what they should be in a plus bi forms, and then multiply them together using the distributive property. So let's check our work over here. Compare our answer. Okay. So what is z? Well, z is root 2 times the cosine of pi over 4, root 2 times the sine of pi, I sine pi over 4. And this number right here is root 2 over 2. This is also root 2 over 2. And when I multiply root 2 times root 2, that root cancels. So z is 1 plus I. Square root of 2 times root 2 over 2 gives me 2 over 2, which is 1. And w, if I figure out what these are, this one's negative root 2 over 2, and this one is positive root 2 over 2. Cosine of 3 pi over 4 is negative, and sine of 3 pi over 4 is positive. See if you guys can, you can see that. There you go, just a little bit. And so w will equal, multiplying by 3 root 2. Root 2 multiplies this root 2 and cancels, so I get -3 plus 3i. That's my z and w in a plus bi form. So let's multiply them together. Z times w equals 1 plus I times -3 plus 3i. Hopefully this is going to equal 6 when I do this. So we've got 1 times -3, so this is -3. 1 times 3i, that's 3i. I times -3, -3i. I times 3i, that's plus 3i squared. Look at that, middle terms are gone, no i's. That's good. No I in my answer. Negative 3 plus 3i squared is negative 3 plus 3 times negative 1, which is negative 6. Boom! Same answer. That's good. So basically, if we were to plot this, what it would look like, I'm going to plot z, plot w. So z is a complex number that's got a distance of root 2 at an angle of pi over 4, and we found that's just the point 1, 1. There's z. And then w has a distance of 3 root 2 at an angle of 3 pi over 4, which we found was the point negative 3, positive 3. There's w. And when we multiplied these two complex numbers together, we got another number that was out here, negative 6. 1, 2, 3, 4, 5, 6. So this is where z times w ends up being. You take z, you take w, and then there's z times w. You add the angles together, so we've got 3/4 of pi, and then we add another 1/4 of pi, and that gives us where we're going, the direction, and we take this magnitude and this magnitude, and we get a magnitude of 6 out. That's how multiplying complex numbers works in polar form. Sweet.